Guys, in this video I'm going to do a pre-calculus problems. I recorded that video when I was doing a review session, so I hope that you're going to enjoy that video. Please let me know if you have any questions and enjoy.
Okay, so I want to start with problem number 5. For this problem, let's do part A, which is give an interval on which f is increasing. And there's two ways how we can do this. I can give you algebraic formula for definition when the function is increasing. But just I'm going to explain your function is increasing if you choose a point. For example, let's call this point x. And you move to the point to the right, let's call this point y. And your function is increasing if after you're going to move to the right, the value of your f of y is going to be strictly bigger than f of x. So okay, at this point I'm forced to write down the algebra definition. So you say that f is increasing if you choose a point x strictly less than y, and from here follows that f of x is strictly less than f of y. So for part A, in this case, you can see if you're given the graph of the function, the way how to start analyze this graph, we need to start with a point which is on less than 5. And you can see if you will choose this point 5, and for this point you will get corresponding f of negative 5. When you will take this point and track to the point to negative 1, you can see that your function is going to increase. So your value of intermediate point is going to get bigger. So that's why since your domain starts with point negative 5, and since for negative 1 you have open circle here, you can see, then your answer is going to be, I have your answer. The function is increasing from negative 5 to negative 1, open parenthesis, union. If you will continue tracking this point, you can see between f of negative 1 to f of 1, your function is going to decrease. So when you're going to move to the right, your slope is actually negative. But from 1 to 5, it's again is going to be positive. Okay. As a practice question, let me sketch some function. And let me indicate the points. So this point is going to be negative 1, sorry, negative 2, negative 1, and let's say 3. So for this function in the red box, can you please type in a group chat or just tell me on what intervals your function is increasing? Tricky part. Okay, and can someone tell me on what intervals your function is decreasing? Okay, perfect. So right now you are able to recognize when your function increasing and decreasing using the graph. So basically, if you have a positive slope, your function goes up, it's increasing, goes down, decreasing. Okay, so let me know if you have any questions about this, and let's move on to the part B, which is range. So for part B, we need to find the region of the function. And range is pretty simple. If you have the graph of the function, the range, you just need to take your function and project onto y-axis, because the range, in other words, is all possible outputs. So the way how to think about this, we can again start with negative 5. It's like a cartoon. So when we're going to start negative 5, my function value, let's say we go from negative 5 to negative 1. And then you can see that values of y is going to be closed circle 4 and it goes up to open circle -2. And then my function changes from -1 to 1. I'm going to start with closed circle -1 and go to the closed circle 1. And when I will continue going from 1 to 5, I will start with open circle 2 and closed circle 4. So in other words, to see this, I'm just projecting my function onto y-axis. So it's going to be like these projections. So answer for this problem is going to be for part B, from negative, I believe, 4 to -2 open circle, union from -1 to 1, and union from 2 to 4. And 2, I did a mistake, is going to be an open parenthesis. Okay, so if you did this problem, you just let me know if you got the same answer. But again, let me give you another function as like to practice finding the range of this function. Okay, so let me give you the numbers. So let's say this is going to be the number -4. This is -2. Obvious 1, 0. This is 2, 3, and this number is 4. So can you please tell me or type what is the range of this function f? And don't tell me right away, like wait for 10-15 seconds because I want to sketch the second function meanwhile. We do projection. So this line, if it's going to project, I will gonna just get a single point, -4. And then here I will open bracket, and the projection of my function goes until like this point over here, which is also going to be open bracket. And then again, projection of just single point. So from this, we can see that we're going to have like -4. Usually we indicate like this, union from -2 to 2, sorry, to 3, union 4. Okay, perfect. Can you do, guys, the second function? Can you find the range for the second function? Yeah, correct. So it's going to be, again, like 0 is the value because f of 0 is equal to 0. And then all other values are going to be projected onto interval from 1 to +infinity along y-axis. So my range in this case is going to be range of f 0 union 1 open bracket to +infinity. Okay, perfect. So I hope like these two examples were helpful for you. For part C, we want to estimate f inverse of -3. So to estimate f inverse of -3, let's try to rephrase this using English. So I'm going to use like two approaches. The first approach, we want to find, since f inverse, the input for f inverse is going to be the range of your function, and the output is going to domain. And we are asking for which output negatives, what input do I need to take to get the output to be equal to -3? Okay, so if you don't like this approach, we want to find f of inverse 3 is equal to x. And to figure this out, I'm going to just apply function f to the both sides. Can anyone tell me what is f inverse, f composition f inverse of 3 is equal to, and why? In other words, I'm going to give you a hint, like a rephrase. What is going to happen if you're going to apply inverse function and then f for your output x? What is going to happen with your output? It's not flips, so yeah. Okay, so let me see. Yeah, the output is going to be the original input. This is a property of the inverse function. And I believe I gave you this problem for your worksheet. I don't remember, like 1.4 or something like that. So the property is the following. Let me just write. So f of f inverse of x is equal to x. Or if I'm going to rewrite, if I'm going to plug in, instead of x, f inverse of x to my original function, then the output is going to be equal to x. Okay, so this thing is equal to 3. So basically, I want to find for each f of x, my output is 3. So before, what we did is just summary. We remind ourselves what does it mean for the function f to be to have an inverse f inverse, by just using like algebra notation. But let's actually answer part C. So so I have -3. So we have -3 over here. No, -3 over here, and you can see that what x do you need to choose to get this value over here? And this x is exactly -3. So from here follows that x is equal to -3. Please let me know if you have any questions. So another way to solve this problem, let me just draw you the picture. F goes the following way. You choose your value x, and you apply your f, and you get this value. But f inverse goes opposite direction. F inverse goes, you choose your value here, which is -3. You apply your f inverse of -3, and you can see what is your value is x equal to -3. This is another way to solve this problem.
Okay, thank you.
Okay, for now you see like 2 different approaches how you can do the problem. Okay, so on this note, let me give you some function to practice. Okay, so right now for this problem, I want you to find approximately the following values. So first, find me what is, sorry, I didn't finish. Tell me what is f of inverse of -4. What is approximately f of 2? And what is f inverse of 4? So let's say this is A, B, and C. So we can see that for -4, -3, yes, correct, because it's going to be this value. For f of 2 is 1, correct, because f of 2 is just this value. And f of -4 was a little bit tricky, but the whole trick is value of your functions already lies in the y-axis. And your input to get this is 0. Okay, so let me clear the drawings. So for part D, right now I want to find the domain of f inverse. Can anyone tell me actually the answer for this one, and can you explain how did you get your answer? And before that, we found the range of f, and let me just remind the range of f for 4 to -2, union close bracket from -1 to 1, union open bracket from 2 to 4 close bracket. It's going to be for D like CB. So it's going to be this answer. Okay, cool. So let me know if you have any questions about this. Let's do last part. So is function even, odd, both, neither? So before we're going to answer this question, let's practice a little. First, can anyone remind me, right now I have Cartesian coordinates, and I want to sketch function f of x, which is even. Can you give me an example of the even function, or can you tell me how do I need to sketch my f of x on this graph in a way that the graph that I'm going to get is going to be the graph of the even function? Okay, yeah, so a good example, so the GL is going to be x squared, and the graph of this function looks like this. But let me elaborate a little bit about what does it mean for the function to be even. We're saying that function f is even if f of x is equal to f of -x. Let me explain this based on this example. So first, let me just show you how to prove algebraically that x squared is even. So right now I want to show that this function is even. So to show this, what literally I need to do, I need to write f of x, I need to write f of negative x and check that they're the same. F of x is equal to x squared. F of negative x is equal to negative x squared. But since I have like negative x times negative x, remember, negative will get canceled. So I'll have x squared. So the actual is the same. So this is like algebraic proof how to show that function is even, just evaluate your function. To understand what's the meaning of even based on the graph, let's say we want to sketch y is equal to x squared only for positive x. And we're going to get this function, like a half of parabola. And your function is even if the outputs for the negative values is going to be the same as outputs for the positive values. Or in other words, your function is even if it's symmetric along the reflection y-axis. And you can see parabola is symmetric along the reflection for y-axis. Okay, good. So let's do the same for odd function. So can anyone tell me either the definition or give the example of the odd function? Okay, yeah. So we have like cubic and we got the definition, but let me show you the simplest example. The simplest example of function of which is even is f of x is equal to x. To show it algebraically, I need to show that f of x is equal, f of negative x is equal to negative f of x. This is a definition, algebraic definition of function to be odd. And to check this, I'm going to evaluate left-hand side. If I'm going to plug in negative x, I will get this. But it's exactly the same if I'm going to keep my x the same, this negative sign. So you can see that function is odd. But to understand how to say geometrically when you use a function is odd, imagine that you sketch your function only for positive value of x. And your function is odd if you will choose some input. Let's call it x. Then you will take the opposite input, in other words, negative x, and the output for this negative x is going to be your original output, but with negative sign. So that's why you're going to have this. Or in other words, you can see that your function is odd. Let's say, have the practical version. Your function is odd if you take this line, you reflect your function along y-axis, and reflect your function along x-axis. So you're doing like this to rotation. So if you're given the function you want to answer if your function even or odd, you need to reflect and reflect. Okay, let me show you an example with a cubic parabola, for example, to show that it's odd. So what you're doing, you're taking your positive value, you're reflecting along x-axis, and then reflecting along y-axis, and then reflecting along x-axis, and you're gonna get the match. Please don't know, like put thumbs up if you got it, or if it's clear, or if you have any questions, but we're going to use this approach to figure out the answer for E. But can you give me an example of the function which is at the same time as even and odd? To say some function is neither, you need to show that your function doesn't satisfy this equality, and your function doesn't satisfy this equality. It's to answer this one. Okay. So finally, let's enter the problem. To check that this function even, again, I'm taking like this positive values. And unfortunately, this function is not even, because if it was even, when I'm going to reflect this function along y-axis, it doesn't match with my original function. But again, like you can see, if I'm going to reflect this my function again along y-axis, so first I did like this first reflection, then I'm going to do this reflection. This line segment will go to this one, and this line segment over here will go to this one. And since your function is symmetric along x rotation and y rotation, then this means again that this function is odd. Please let me know if you have any questions. An example of the function which is both even and odd is the following. Let's take function y f of x is equal to 0. You can see that reflection along x-axis is going to give you exactly this, like half interval. But if you're going to reflect along y-axis, half interval goes to half interval. So, or like x-axis will go to x-axis. So that's why f of x 0 is both even and odd, and it actually satisfies both these inequalities. But before we go into problem number 4, actually, I want to review some other stuff. So let's start with this simple notion, finding the equation of lines. So let's say I have like 2 points. Let's take point A, I don't know, let me think. Let's take 3, 1. Let's take point B, which is equal to 1, 2. And for these 2 points, I want you to do the following thing. So first, sketch A and B. Second one, sketch the line that goes through A and B. 3, tell me, is this line like increasing or decreasing? So it's like increasing or decreasing function. So yeah, I'm gonna give you like, let's say like 4, 5 minutes, like 3 minutes, 4, I don't know, 5. Let's say 4, and try to answer all these 3 questions. Oh, and the last one, the most important one, find the equation of the line. This is the whole point of this problem. Okay, 3 minutes has passed. So sorry. So let me just do part 1, 2, 3, and 4. So for part 1, let me sketch Cartesian coordinates, and I have point A, which is 3, 1. So 1, 2, 3, 1. Point B is 1 and 2. So this is my A, 3, 1, B, 1, 2. Okay, so part 1. For part 2, sketch the lines that go through A and B. Remember, like to sketch, if you want to sketch a line, you need to have at least 2 points. Because if you will choose 1 point, you can sketch infinitely many lines through this point. But as soon as you choose a point and one other point, then you can sketch a unique line that goes through these 2 points. So that's why I'm going to have this line over here. So that's why I check for part 2. So is this function increasing or decreasing? And I guess you can see from the graph, as soon as you got the graph, that the function is decreasing. And please let me know if you have any questions. So the function is decreasing, so check. And finally, right now is the most interesting one, how to find the equation of the line. So first, can please anyone remind me what is the general, like what is the general form of the equation of the line? Yeah, so it's y is equal to mx plus b. Good. So can anyone tell me what is m and what is b? So what is the meaning of m and what is the meaning of b? Okay, so let me check what someone texted. Yeah, m is slope, yes. But what about b? Yeah, it's y-intersect. But why is it y-intersect? How to show this? You'll have m times 0 plus b is equal to b. And this is like when your x value is 0. So an x value 0 is exactly here. So, okay. And let me just sketch you a couple of pictures. So for example, let me think. Can you, as a practice right now, can you sketch please y is equal to 2x minus plus 3. So I'm going to give you a hint. I mentioned before you need only 2 points. So can you just tell me any 2 points for which belongs to this line? And tell me how you can find those points, or what do you need to do? Okay, 1 and 5, yes, that's a good point. But there is, yeah, so, but let me tell you, let me show you kind of the trick which allows you to sketch the line pretty fast. The first point is pretty simple. You just need to set your x to be equal to 0. So that's why you'll get 0 times 2 plus 3. So when x equal to 0, my output is this point, 0, 3. But the second simplest point to find, it's when your line is going to intersect x-axis. If your line intersects x-axis, what is the value of your y? Y is equal to 0. So if you will take right now y is equal to 0, but y is equal to 2x plus 3, you can see this both equation will give you that 2x plus 3 is equal to 0. So x is equal to -3 over 2. But -3 over 2 is exactly -1.5. So let's say this is going to be my 1, this is going to be 2. So this is my second point, -1.5 and 0. And so line goes something like this. So every time when you sketch the line, I would recommend just plug in x equals 0 and set your y equal to 0. And yeah, and you can see here the function is increasing. But finally, let's answer for part 4. So we have this form y is equal to mx plus b. So can anyone tell me, if I want to find the equation of this line, what do you need to do? What do you need to find? Yeah, slope and y-intercept. So to find the slope, so m is going to be, I don't remember how it's like, rise over run. And to find this is the following idea. So we go from point B to point A. So we have this triangle. This side over here is going to be your rise. This side over here, let me use different color, is going to be your run. So can anyone tell me what is your rise in terms of like, value? How to find rise? What do you need to do? Rise is actually -1. To find the rise, you take your point, which is 1, and minus your y value for, so you take the y value of ending point, which is 1, and subtracting the y value of initial point, which is 2. And what is your run? Run is 2, yes. So I take x value, sorry, for my x and subtracting y value, sorry, x value for my initial point. So it's going to be 2. So you can see slope is equal -1 over 2. Okay, perfect. So right now we know our slope, and we can say like check for m. So can anyone tell me what is your, what is our b? How to find b? What do you need to do? I'm going to give you a small hint. Right now we know that m is equal to -1 over 2. So I can rewrite my equation, and I'm going to get that y is equal to -1 over 2x plus b. So the question is right now how to find this b. Yes, so we know 2 points. Let's take point 1, 2. So my output is 2, and my input is 1. So when I'm going to plug in this point, I can see that then b is equal to 2 plus 1/2. So it's equal to 3 over, sorry, not 3, 5 over 2. Because 2 is just 4 over 2, so 1 over 2 plus 4 over 2 is 5 over 2. Okay, good. So final equation of the line is going to be y is equal to negative 1 over 2x plus 5 over 2. Please let me know if you have any questions. I'm going to erase. I'm not solving the problem number 4. I'm doing a sample practice. This problem for you to be comfortable talking about lines, finding the equations, sketching them. So yeah, so I'm raising the notes and let's come back to this problem. So first, find the equation for the line that is perpendicular to the line and passes through the vertex of the parabola. So I'm going to tell you how to say 2 important facts. And you can use these 2 important facts to solve this problem. The first idea is that you need to do to find the equation of the line. I will say just equation of the line. You need either 2 points, as we did before, to know 2 points. You need to know the slope and 1 point. So basically, idea of 2 points is because you have 2 points, you can find the slope. But sometimes you can be kind of given a slope and 1 other point, and you want to find your function. Sorry, the equation of the line. Okay. Actually, I'm going to tell you 3 facts. So if you have a function y is equal to mx plus b, let's call it y1, and you have function y2, which is equal to m2 plus xb. And we know, let's just sketch these 2 functions, 2 lines. I have, this is my y1, this is going to be my y2. So m1 is the slope of the first function, m2 is the slope for the second function. Sorry, like for the second line. And we know these 2 lines are perpendicular. Can you tell me what is your m2, what does your m2 is equal to in terms of the slope for the first function? The negative, yeah, that's perfect. So the slope is equal to -1 over m1. As the reason is the following, I can just draw you the short picture to. So for example, to understand why, let's see, let's take this rise over run. So this is rise and this is run. So if we have another line which is perpendicular, that looks like this. Yes. This line is going to be like, goes to the infinity. I'm going to flip my rise and run. So that's why I'm going to have rise here and run here. And if I'm going to say that, let's call it like this is going to be m2, is going to be equal rise over run. But you can see that for my m1, so first my function was first increasing, but then it got decreasing. That's why I'm going to put minus sign. And then I'm switch my rise over run. So we'll have run over rise. But this is equal to 1 over negative for m1. So it's equal to -1 over m1. So this is the second fact. And the third fact, if you have y is equal to x squared plus 4x minus 1, can you tell me what do you need to do to find the vertices, the vertex of the parabola in this case? Or how to find the vertex? I'm gonna say, how to say, the solution, the phrase which you're not going to like. Yeah, put in the vertex form, but we're going to put in the vertex form by completing the square. And unfortunately, like, students don't like completing the square. Let me just show how I do completing the square. You can either like, I don't know, if you like it, you can try the same approach. If you don't like it, just use your approach. So completing the square means if I will take x plus a squared, it's equal to x squared plus 2ax plus a squared. So completing the square means I'm starting with the right-hand side and moving to the left-hand side. So I'm starting with some sum of quadratic, and I want to complete the square. The same idea here, but let's do a small trick. When we're completing the square, when we have this right-hand side, we want to have 2, we want to have a, and we want to have x. As soon as we know what is your a, you can basically write your left-hand side, but you need to check that if you know your a, you also have a squared. But if you're not going to have a squared, what you can do, you can add a squared and subtract a squared. So let me show you in the practice what's going on. So I have x squared, so I want to get 2, but I can write 4 as 2 times 2 times x. So you can see right now I have my 2 over here, and I have my a. And a in this case is equal to 2. But also I need to have a squared. In this case, a is equal to 2. So a squared is 4. So to get a squared, I will need to add 4 and subtract 4. Let me do this in a row. Because if you have number 0 is equal to 4 minus 4. But also I have this number -1. Then this guy over here is exactly equal to x squared plus 2 times 2x plus 2 squared, which is equal to x plus 2 squared. So it's equal to x plus 2 squared. And then -4, -5 is equal to -5. So my vertex form for this parabola is equal to this expression. So right now I have this equation. Can you tell me, please, what is the coordinate of the vertex for this parabola? Yeah, it's -2, 5. How to see this? To find the vertex, you need to set your x to be equal to the opposite value of like the numbers that you're adding or subtracting. So in this case, I will have x plus 2 is equal to 0, so x is equal to -2. But when x is equal to -2, your y is equal to -5. But another approach how to think about this, we start with a parabola y is equal to x squared, and we're going to get parabola which is y is equal to x plus 2 squared minus 5. Can you tell me what kind of function transformations do you need to perform, and how many function transformations to get from y is equal to x squared to y is equal to x plus 2 squared minus 5? So I'm starting with regular parabola. I want to obtain the parabola here on the bottom. How many function transformations do you need to do? And can you describe the order of them? Yeah, but since here 2 is positive, it's translation not to the right but to the left. So first, if I have this parabola, my first translation is going to be I will go to 2 units to the left. So this is going to be y is equal to x plus 2 squared. Because you can see if you will plug in x is equal to -2, your y will be equal to 0. And then I'm going to go 5 units down. So we'll go like this. And you can see here, this is point -2 and this point -5. So you start with a vertex with coordinates 0, 0. And then you will get the vertex with coordinates -2 and 5. So let me finally say just like 2 sentences, and you will know how to do the problem. To find the equation of the line, I need to find the slope and a point or 2 points. The line that I want to find, I know it's perpendicular to this line. So can you tell me what is your slope is equal to?
-1/3.
Yeah. And I need to have 1 point. But I know that this line goes through the vertex of the parabola. Can you tell me the coordinates of your point? Yeah. This is exactly the vertex that we found. So slope is -1/3, and vertex of point is -2 and -5. And the thing that we did previously, so you know that your function is going to be equal y is equal to -1/3x plus b. And to find b, you just need to take your point -2 and -5 and plug in inside your function. And you're going to find the equations y. Okay. So at this point, we're done with reviewing the midterm. So I not only did the problem number 4 and number 5, but also we talk about other different stuff. So about odd, even functions, increasing, decreasing, finding the equation of the line, computing the square, and all other stuff. Okay, so let's say I'm gonna stay here for extra 5, 6, 7 minutes and just take your questions and answer your questions. And after that, I will say good luck on your midterm, and I will see you on Monday. Okay, sure. So let me just erase. Let's complete the square, for example, for, let's do this the most simplest one. Let's complete the square is this one. So completing the square means I will start with this equation, like I'm going to use this formula, yes? So I have left-hand side, and I know this is equal to x plus a squared. So to complete the square, I need to make my left-hand side look to have this form plus minus something else. So here what I'm going to do, I'm going to create this left-hand side. So I have x squared plus 2, and I need to have my a. But what is my a in this case? I can write 2 times 1 times x. So a in this case is equal to 1. But do I have a squared over here? No, like I don't, yes? So what do you need to do? You need to add 1 and subtract 1, or not like 1 squared. And then we can see that my equation will be x squared plus 2 times a times x plus a squared minus a squared. And this guy over here is exactly like x squared plus 2 times 1 times x plus 1 squared, yes? But according to this formula over here, like this guy is just equal to x plus a squared. But since a is equal to 1, I will just put 1 here. In other words, let me just show you one more example, but I'm going to do it like just really fast. Let's do like x squared plus 3x plus 2. So the idea is the following. You're going to write your x squared. You take your number, which is in front of x, and what you can do with this number, you can multiply by 2 this number and divide by 2. Because 2 and 2 will get canceled and you will get x back. Does it make sense? Yeah, and right now you know this is your a, and you want to have a squared in your formula. So what you're going to do, you're going to rewrite what you have, x squared plus 2 times 3 over 2x. You're going to add a squared and subtract a squared. But don't forget about your extra number. And then this guy over here is going to be x plus 3 over 2 squared minus 9 over 4 plus 2. And there's some other number. And that's it. Okay, let me stop recording.